every body continues its state of rest or state of motion until and unless acted upon by an external force. So that is one thing. So what is this? There's nothing but you can call law of inertia. This you can also call it as law of inertia. I mean, suppose say a body it is at rest. Why it is at rest? Because of inertia of rest. That one. And until unless you don't apply any external force, it will not undergo displacement. It will continue its state of rest here. So any reason for that? Because of the inertia. So what is inertia? The measure of mass of a body. It's nothing but called as inertia. The mass itself is nothing but we are calling it as the inertia here. There's one another name what we'll put it here. Now why do the body will continue its state of rest? As long as there is no applied force, so it will continue state of rest. Similarly, if a body is in uniform velocity motion, it will continue in space it is moving. Then why it is in motion? Because of inertia of motion. So here what we can see that one, inertia of motion. This is very important. We do have many numericals related to this idea. This is the inertia of rest. So in a space, why the body will continue its uniform velocity motion? Why the body will continue its uniform velocity motion? Because there's no external force acting on it, and it'll continue its inertia of motion. That way, there's no need of any external agent. As long as there's no external force, it will continue its uniform velocity motion. As long as there's no external force, it will continue its state of rest here. So that's what the first law is telling. Here what happened, we came across the two words, inertia of rest, inertia of motion. Second one, the net external force is directly proportional to rate of change of momentum. F equal to m dv bar by dt, or this is m a bar. What is velocity? Rate of change of momentum. No, let me write dp bar by dt, or this will be mv bar. M you take outside, as it is a constant. Mass of a body is a constant. So v bar is velocity, no? V bar is velocity. dv bar by dt will become acceleration. So f bar equal to m a bar, or acceleration is equal to f bar by m. So where this already you know what you mean by acceleration. So like that, the external force and the acceleration are related by this equation. This is what I think we'll be using almost in every numerical. What is that? Net external force it is. So in the third one, action and reaction are equal and opposite in nature. This will be a little bit, everyone knows, as far as our numericals are concerned, no? Our numericals are concerned. I will write it in another way for that one. Force always occur in pair. This is very important. Action, reaction, equal and opposite. Yes, you are quite familiar from high school. Let me put it in a very simplified way where in numericals it's going to help. Force always occur in pair. You take any force, it will always occur in pair. Isolated force not possible. That's what the Newton's third law is, what we are going to use in the numericals here. This is about law of inertia. This first law is called as law of inertia. Second law is called as law of momentum. Like the change in momentum of body when action force acts. This is like a action reaction are equivalent, opposite in nature. Or force always occur in pair. Okay, now after getting the, we are introducing to the word force here now. So let's concentrate on the force. What do you mean by the force here now? The push or pull the push or pull exerted on a body. So how to apply force? By pushing or pulling an object. I think this is a very familiar thing which everyone knows, like that one. You see, this is the chapter where you need a lot of common sense rather than physics or any other thing. First of all, if you have any notebook or something, no, or bag, any whatever you have, water bottle, no, push it. So by pushing, what happen? You are applying a force. The push or pull exerted on a body, what happen? Will set up a force. Kitchen is the best thing to learn our physics. I'm telling you, sir. Today, what happen? You can start sitting. Whenever I give assignment, no, sit in kitchen. In kitchen, you do get wide varieties of different shaped objects. Then easily you can understand, okay, what sir is explaining, no, something related to these objects only, you can feel. The push or pull exerted on a body will set up a force, is telling. Push. What do you mean by push? I think all of you know pushing. You push the door, nothing but you're applying a force. You are push a notebook, you push a table, you push a wall, nothing but you are applying force. You push your brother, sister, or your parent, that one. So gentle push, you put it, nothing but you are applying a force. So how to generate a force? By a push or a pull. What do you mean by pull? You can hold and pull it, any object like this. So now I'm pulling what happened? My t-shirt, that one. Then nothing but pulling it is called as. So even I'm pulling my hair. Is it okay? So I'm pushing my head. These are very generalized things. So here you can see this. So what I'm doing, I'm trying to pull, no? I'm trying to pull out the lid like this, we can see here. So what do you mean by pushing? So if I do like this, I'm pushing, able to analyze here. So like this, what happened? The push or a pull, we do express here. So by how to apply a force on a body? By pushing an object or by pulling an object. How to pull? There are many ways are there. Pulling is that one. Like I can tie a rope to an object and I can pull it. So these are very generalized things which you might have played when you were a kid here. So nothing but already long back, the moment you started moving, you started moving, no, then what, when you started applying the force, it's not that something today I'm teaching, then you are understanding. For long back, practically you started using this force concept here. You have to open eyes, that's all here. So today what you are supposed to do, try to push various objects and try to see that particular motion. What is the unit for this? The unit for force will be Newton. The unit for force, SI unit will define only SI unit, will be Newton. Capital letters, the symbol for unit will be N. Okay, this is about the idea of the force. So there are different types of, again, the forces will come into picture. So what are the various forces that we do come across? So first is the tension. This is what where set up in a rope. Set up or generated in a rope. Set up in a rope or thread or string. What all that force that is set up in a rope or a thread or string, it is called as a tension. Okay, tension is a force, that one. that particular force set up in a rope or a string or a thread is called as a tension. So what do you mean by this? We are not, I think, okay, no, let me just introduce. Later on, we'll go for the nature of all that particular thing. So this is about tension. Next again, the gravitational force. Gravitational force. So this, I think, example of this is the weight of the object. No? So example of this is weight of an object. Third one, electrostatic force. This is due to setup or select it is or generated due to just will have awareness of all the forces what we come across. Huh? Screen not responding. Just okay, fine. Yeah. Okay.
Sir,
Yeah.
sir, can you please minimize the screen a bit, sir?
What happened?
Can you minimize the screen, sir?
Screen minimization. I'm not getting.
Size can be decreased, sir.
Size cannot be decreased. Why?
Your video, that one is blocking, sir.
You are in viewing laptop or
Phone, sir.
phone? Huh?
Sir.
So I should remove video.
No, not like that, sir. Like, I'm not able to see some of the content.
That one. Okay, okay. Then I'll do one thing. So yeah. Oh, okay. I understood. I understood.
Yes. Thank you, sir.
Electrostatic force. I'll write it here. Electrostatic force. So it is generated due to interaction of charges. So there's a gravitational force, electrostatic force, next magnetic force. Generated due to interaction of magnetic pole. Generated due to interaction of magnetic poles. So next we have nuclear force. Generated due to interaction of nucleons. Okay, these are the some basic forces. I'm just listing out all. So afterwards we'll get normal contact force. Normal contact. It is due to setup due to interaction. Setup due to interaction of two surfaces. Next we have friction set up due to interaction of two surfaces. Okay, after this we have one more. Elastic forces. It is a molecular generated due to interaction of molecules. Like this, these are the different types of the forces what you do come across. Huh? These are the total physics what we discussed. No, these are the types of next electromagnetic force. That one, last one, electromagnetic forces generated due to electromagnetic force generated again generated due to interaction of molecules. Better, you're right. Generated due to acceleration of charged particle. So like this, briefly, we are summarizing the various forces which we do come across. So one by one, what happen as our chapter proceeds, no, we are going to focus on one by one. So in this chapter, well, primary focus will be the weight, normal contact, tension, and elastic forces. These four forces is what I'm going to focus now. And related to that, we are going to discuss the numericals here. So one more, the reaction also like a stress in the rod, nothing but it's elastic force only. Or will just confine to 9. So regarding electromagnetic, nuclear force, magnetic, electrostatic, when that concerned chapter comes, we'll go in detail. So what are the things which will work out now? Even friction also. Well, and next further these things. Is it okay? So these are the types of forces which will be focusing more in this particular chapter. Fine?
Yes, sir.
Okay, let me first start with the idea of the tension. Tension, we'll just call the name of force itself is called as a tension here, not like the psychological